Hello students, welcome back to the lecture series on discrete mathematics. This is logic part 6 video. We are on the first topic, which is propositional logic and propositional equivalences. Let us see the definition of tautology, contradiction and contingency. Since we have already seen the truth table, let us see the tautology concept. A compound proposition that is always true no matter what the truth values of the propositional variables that occur in it is called a tautology. Or, in general, a compound proposition is a tautology if it contains only t in the last column of its truth table. It is denoted by t. So, whenever a compound statement or compound proposition is given, we are going to construct its truth table. And if it in the last column it is always true, we say that it is a tautology. It also means that in any case we have the truth value as true. It is always true for all possible values of the propositional variables. So the next definition is contradiction. A compound proposition that is always false no matter what the truth values of the propositional variables that occur in it is called a contradiction. Or in general, a compound proposition is a contradiction if it contains only f in the last column of its truth table. It is denoted by f, a contradiction. That means when the truth table is constructed and we have f in the last column of the truth table, it is a contradiction. That means in all the cases, in all possible values of t and f, we are getting the truth value as false for that particular compound statement. Now contingency means a compound proposition that is neither a tautology nor a contradiction. That means not all the entries in the last column are true or not all of them are false. In that case, we have contingency. That means we have maybe few true, few false, or not all of them are the same. Let's see it in the example. Verify whether the following statements are tautology, contradictions, or neither. So the statement is P and Q and negation P. So there are two propositional variables. So the column will contain how many rows? 2 raised to 2. Therefore 4 rows will be there. Third column will be P and Q. Fourth will be negation P. And the fifth will be the compound statement which is given P and Q and negation P. So if you see this, we observe that P and Q, the statement is true, false, false, false. Then in the negation P, we have false, false, true, true. But in the last column, consider the third and the fourth column. And we see that the AND statement is true only if the two columns have the truth value at the same time. But that is not the case, and hence we are getting false everywhere. And since the last column contains all f's, the given statement is a contradiction. It is not true in any case. Means for all possible propositional variable values, we have the false statement and it's a contradiction. Let us go to the next example, which is P implies Q if and only if negation P implies Q. So let us see this example. Now the two propositional variables are there. That means the number of rows will be 2 raised to 2. That means 4. So P implies Q statement is false if P is true and Q is false. So the third column is TF double T. Then the negation P is FFTT. The negation P implies negation Q. That means we are going from fourth column towards the second column. Be careful here. So implication is false if fourth column is true and the second column is false. That this is happening in the last row and that entry is false. The rest of the entries are true. And the last statement, double implication, is true if both of them are true and is false if elsewhere. So the last column contains F's as well as T's. Therefore, the given statement is a contingency. We are not able to decide, and it depends on the case whether it is true or false. Let us see this one. Verify the following statements are tautologies, contradiction, or neither. The statement is P implies Q and negation Q implies negation P. So the number of rows will be 4. The first two columns will be P and Q, and third column is P implies Q. Then we got negation Q, then the and statement for the P implies Q and negation Q, then negation P and P implies Q and negation Q, the whole implying negation P. Since in the last column again we have all the truth values as T, we have the statement as tautology, we have the compound statement as tautology. So we may have the question, verify whether the following statements are tautology, contradiction, or neither. So with the help of the truth table, which we have already learned how to construct the truth table for the compound statements, we can check whether the given compound statement is tautology, contradiction, or contingency. Okay, we have finished this. See you in the next lecture. Thank you.